Okay, this is part 2 of our lesson 8.10 AP Calculus Curriculum, volume with disk method revolving around other axes. We're calculating volume solids of revolution using definite integrals. This time we are going to do a couple of examples using the disk method to revolve around other horizontal axes, not the x-axis, or not the y-axis, not the x-axis. We're going to start with the problem. Let R be the region bound by the y-axis, the line x equals 2 pi, f of x equals sine x, and the line y equals 4. Well, that sounds like a complicated region. Find the volume of the solid created by revolving the region R around the line y equals 4. So let's look first at a graph and see what this region looks like. We've got the x-axis, the y-axis. We've got the graph of y equals sine x. From 0 to 2 pi. We got the vertical line x equals 2 pi. And we've got the line y equals 4. And so it looks like this region is what we're going to revolve around the line y equals 4. So I'm going to draw one rectangle inside there. Width is dx. If I rotate that around, it creates a disk. I'm going to draw that disk over here. Height of that disk is dx. I need to know the radius. The radius, I'm going to erase some of this so that we can get a little clearer picture. The radius of my disk is the height of that rectangle. Whoops, didn't need to erase all that, did we? Need the curve sine x in there. And so what we see is that rectangle, the height of it is going to be 4 minus sine x. So here it's easy to see 4 minus sine x. Even though when the value of the sine x is negative, though, 4 minus the negative value is going to give us 4 plus however long that is. So this expression for the height of that radius, the rectangle, that's going to be 4 minus sine x. And so the volume of one disk is going to be pi times the radius squared, which is 4 minus sine x, and all of that squared, and then times the height of that disk, and that's dx. To find the volume, we're going to integrate. Here, oops, my mind was 0, x equals 2 pi. So we're going to go from 0 to 2 pi. That's what defines the region. And the volume of one of those, and we'll bring the pi outside because it's a constant multiple, times 4 minus sine x squared dx. As I've often said on the FRQs, that's going to be sufficient. A lot of times they're just going to ask you to set the integral but not evaluate. I'm going to go ahead and type that in my calculator. My calculator still not working on my computer, so until I can get that going again, I'll have to just show you. I'll write down what I enter in this TI-84. But we're going to do math 9 to get the integral up. I'm going to go from 0 to 2 pi. Then inside, I'm going to put in parentheses, inside the parentheses again, 4 minus sine x. Close the parentheses on the sine x, close the parentheses on the 4 minus sine x, then square that. Make sure that quantity is squared, and then times dx. So I'm going to show you again what I've put in the calculator for the TI-84. So I put in here, this is going to be pi times the integral from 0 to 2 pi. And then this is going to say, that's the parentheses automatically opens. I'm going to open a new set of parentheses, do 4 minus sine. Another set of parentheses open, so I got to close the sine x parentheses, close the 4 minus sine x, then square that, then close the parentheses on the integral, and then dx. That's in a calculator. How we enter that in a calculator. And so tell the calculator to integrate that, and we're going to get 103.67. Oh, I haven't multiplied that by pi yet in this calculator. So times pi. Don't forget to multiply by pi. Let's see here. Make sure I didn't multiply by pi first. I didn't. Okay, so it's going to be 325.696 or 697. We usually just chop, and that's going to be units cubed for volume. That's one example. Let's do another example. Let's let R be the region bound by the curve y equals negative x squared plus 9, the vertical line x equals 3, and the horizontal line y equals 9. And we're going to find the volume of the solid generated by revolving R around about the line y equals 9. So again, I'm going to start with a graph. These basic curves, you have to know what the graphs look like. This is a parabola that opens down, intersects the x-axis at -3 and +3. We have the horizontal line x equals 3, or sorry, vertical line x equals 3. Horizontal line y equals 9. That's where the y-intercept is. And so it looks like in this case, the region R is here, bound by those curves. So we're going to integrate and revolve about the line y equals 9. I'm going to draw one rectangle. When we do that, we get the solid generated by the disk generated by that. I'm going to pull it out here. Width is dx again. We're integrating, it's perpendicular to the x-axis. This time, the radius is 9 minus, and this is negative x squared plus 9. 9 minus the curve. This is 9 minus negative x squared plus 9. This height is negative x squared plus 9. So you add them all together, you get 9. I'm going to find the volume of one of those cross sections. That's going to be pi times the radius. Let's go ahead and clean this up, because 9 minus negative x squared makes 9 plus x squared, and then minus 9 makes the 9's cancel. This just gives me x squared squared, or x to the 4th times dx. And so the volume is pi times x to the 4th dx. I'm going to integrate that from x equals 0 to 3. That's my region. Bring the pi outside, it's constant multiple, x to the 4th dx. This is going to equal pi times x to the 5th over 5. Oops, not dx. Evaluated from 0 to 3. That's going to be pi times 3 to the 5th. That's 81, 243, 729. Oh, sorry, 243. Yeah, okay, I was off. 243. Divided by 5 minus 0. So this is going to be 243 pi over 5 units cubed. And that's a couple of examples of revolving using this method, find the volume of solids using the disk method to revolve around other horizontal axes.